Hey guys, this is Lou at LightPoint Scientific and Axiom Forensic, and this is an Excel primer for my Motorcycle Collision Reconstruction course. And the purpose here is to familiarize everybody with Excel so that we can go through some of the examples in the class and the exercises in the class using Excel. And the reason why Excel is so powerful for collision reconstruction, motorcycle collision reconstruction specifically, is because there are often a lot of parameters that we don't know the exact answer to. So for instance, if you have a car skidding for 100 feet or something, the coefficient of friction or the drag factor for that car is pretty well established. We know it's going to be within a pretty tight range. For motorcycle collision reconstruction, that range might not be as tight because we might not know if they're using the front brake in combination with the rear brake or if they're only using the rear brake alone. Similarly, impact speed generally has a wider range for a motorcycle versus a car because you might not have black box data for the motorcycle and momentum analysis is pretty much out of the window for most instances. So it's really important to be able to perform sensitivity analyses with motorcycle collision reconstruction, especially if you are doing some sort of momentum. The momentum is generally going to be angular momentum, but at times it could be linear momentum. And it's also important to analyze the ranges that you're using for your variables. So there's a few ways to do that. One is just by setting up the equations in Excel and then changing what you have for numbers. And then the other option is to perform a Monte Carlo analysis, so some sort of statistical analysis of the variables to determine, hey, based on all of these potential ranges, what is the likely speed of the motorcycle, say, at the initiation of the braking maneuver. So that's why Excel is really, really valuable, especially for motorcycle collision reconstruction, and it's not that difficult to use. If you're used to the Microsoft suite, it won't be that difficult for you to move over to Excel. And I'm just going to show you some of the basics of it right now and how I would set up a fundamental spreadsheet to perform some calculations for the initial speed of the motorcycle. And if you're able to follow along with this and perform some of these calculations yourself, then you'll be well primed to succeed in the motorcycle collision reconstruction course. So we're going to switch over to the screen now, and I'll show you the introduction to the Excel format, and we'll do some calculations. Okay, so this is what you'll see if you open up a new Excel spreadsheet. And as you can see across the top, each column has a letter, A through, it goes forever, but A through Z, and then it goes to AABB, or AAAB. And then each row has a number associated with it, so 1, 2, 3, 4, to I think it goes to some huge number like 65,000 or more. And each cell is identified by stating what the column letter is and what the row number is. So right now where my cursor is, that's F4. And you can see up here in this little box, the name box, it shows what cell the box is currently highlighting. So that's important when you're doing math because you'll be referencing certain cell numbers. But I'm just going to go over some really basic stuff. So in this cell, let's just stick with F4. If we wanted to know what 4 times 27 is, you just hit equals on the keyboard and then 4 times 27. And here the asterisk is going to be multiplication. So equals 4 times 27, hit enter, and you'll get 108. A very common mistake is to just go into that cell and then hit 4 times 27, and then it'll just stay as a non-function. You'll get each character that you typed. So just make sure you hit equals first, and then that tells Excel that you're going to be doing some mathematics. So 4 times 27 is 108. Multiplication is the asterisk, and then negative is just the dash is negative, which I think is probably expected. So 4 negative dash 27, 4 minus 27 gives you negative 23. And then addition is the positive symbol, the plus symbol, which again, self-explanatory. Division, very similar, so equals 4, and we'll divide by 27, so the backslash is divide, and that'll give you the answer in decimals. So there's a little bit of formatting here, depending on how much you want to get into it. I tend to make my spreadsheets pretty organized and aesthetically pleasing. It's just my nature. But here, so depending on what you're getting, say you're getting a speed or something where you don't really want to round it to, say the speed that you calculate is 35.02783, whatever it is, we have here 35.2748445. But if you just wanted to show the whole number, you can come up here to the number pane in the home ribbon and decrease the number of decimals or increase the number of decimals. And you can select a whole set of cells and use those, and it'll format them all the same. Okay, so that's a little bit of the basics. So let's do an example. I have one set up here from the course, and here's the question. So how long in feet or meters does it take a motorcycle to come to a complete stop from 35 miles per hour if the rider's perception response time is 1.3 seconds and the deceleration rate is 0.65 Gs? And then the question asks for you to plot the stopping distance from 35 to 50 miles an hour using 5 mile an hour increments. So I'm going to put that over to my other screen just so I have it referenced and then start working on it over here. So the way that I set up my Excel spreadsheet is I always work in consistent units when I'm doing collision reconstruction mathematics, or really any mathematics. So for that reason, I set my spreadsheet up like this. I just type in parameter, and that'll be like initial speed, skidding, sliding distance, skidding distance, whatever's going on. Parameter, then I do value, units, and then I do value units again. So here, by the way, I'm just moving around. You can either use the arrows to move around, or you can use tab or return. So when I'm done typing in parameter, if I hit tab, it goes over to the next column. If I hit enter, it goes down the row. Between using the mouse, where you can just click on any cell, or you can use the arrows, or you can use enter or tab. Okay, so now I have that, and I often just turn this into a different color to differentiate it so that we know it's a heading, and Control B if you want to make it bold, Control U if you want to underline it, Control I if you want to make it italicized, just like any other Microsoft program. I'll generally select this whole section and just center justify it. So if you click up here under the home ribbon again, that's where most of the things you're going to be dealing with are in the home ribbon. And if you just click on the alignment, you can make it left aligned, right justified, or center. Okay, so parameter here, we have the motorcycle. We know it's originally going 35 miles an hour. So I'm going to put initial speed. I'm just going to type that in fully here. Initial speed is 35. Hit tab, miles an hour. And then for me, to get into consistent units that I'm used to working with, I would go to feet per second. You might go to meters per second. Here I'm just going to press enter, press equals, I'm sorry. And then there's a couple ways you can do that. You can just click on this cell, so B2. So it's saying, all right, we're going to take B2, and then to get it to feet per second, we multiply by 5280 divided by 3600. And I try to use parentheses to keep myself organized, and Excel appreciates that. So you have to have those in the right spot. For a situation like this, I think we could do with or without the parentheses. I don't think they're doing anything. Right, same number. But I get in the habit of using them for situations where the order of operations depends on the appropriate use of parentheses. All right, so now I'm going to decrease the decimals here. That's more than I need. Now we have the initial speed in miles an hour and the initial speed in feet per second. We're going to have the rider's PRT. So the rider is basically riding along at 35 miles an hour, sees some sort of hazard, takes 1.3 seconds to respond to that hazard, and then it's going to brake at 0.65 Gs. And the question is, how long does it take for all of that to happen in distance? So here I'm going to put PRT, and that's 1.3 seconds. Units per second, I don't need to convert that to anything that's already consistent. So I'm going to take the cursor and drag and select D3 and E3, and then right click and hit Format Cells. And then you get a bunch of different options, but right now I'm just going to focus on the fill, and I'm going to just tell it to put this cross hatch pattern in there, or diagonal hatch pattern in there. So that just tells me, and it keeps it organized, and I know that there's not anything that I'm supposed to be putting there. All right, so the PRT is 1.3 seconds, and now we can figure out very quickly just what is the PRT distance? How much, what distance did the motorcycle travel during the perception response time? So I usually call that PRT distance. And this is going to be, here we're going to go into the consistent units, so that's feet per second, because we're going to take equals, and it's going to be the PRT multiplied by the initial speed. So we get 66.73 feet per second, and then I'll go back and convert to miles per hour. And that's just, the reason I'm converting to miles an hour is not to further the calculations that are to come, but just to give me, I'm used to working in miles an hour. It makes more sense to me. 66.7 feet per second doesn't mean that much to me. I just want to know what that means in miles per hour. So I'm going to take, actually, I don't like the way that I did that, so I'm just going to be consistent, go equals, then click on 66.7, that cell, D4, and multiply it by 3600 divided by 5280. All right, so that's 45.5 miles per hour. So now we know, geez, that's all distance. I'm sorry. So this actually, PRT distance, that's going to be 66.7 feet. So 1.3 seconds times 51.3. You're probably watching along going, what the heck is he doing there? That's not a speed. So, okay, we have 66 feet for the PRT distance. So before there's any braking at all, it's going to take him, the rider, him or her, 66.7 feet just to start to get to the brakes. And now the next question is, what is the braking distance? So I'll show you what equation we're going to implement to figure that out. Nothing too fancy, but this is just my Northwestern sheet that I have handy whenever I'm doing things to keep myself honest and make sure I don't make a stupid mistake with simple calculations. So we're going to use number 10 here, the distance. So the final speed squared, which is going to be 0, minus the initial speed squared, which is going to be 35 miles an hour, converted to feet per second so that we're staying consistent with our units, divided by 2 times the acceleration. So before we can implement this equation, we need to put the acceleration rate into Excel. So we don't have that yet. So let's just say braking rate, and the problem indicates that that's 0.65 Gs. So negative 0.65. And what I do, whatever you want to do here works for yourself, but I generally just put the drag factor in as positive and then account for that in the subsequent equation. But whatever works best for your brain and the way that you think. So now this is going to be feet per second squared is going to be the equivalent, and I'm just going to take it. So the keys that I'm using here, I just hit equals, and then I use the arrow to go over 2 times. Alternatively, you can click on it. Alternatively, you could type B5, and it'll reference that cell as well. And then times 32.17. So that gets me to feet per second squared. Again, for formatting to keep myself organized and keep everything looking pretty, I would select that too, and then right click, go to Format Cells, and then make that a superscript. Click OK, and then it'll look more appropriate. Okay, so the braking rate is 0.65 Gs, and now we are going to figure out the braking distance. And that is going to be feet. Put the feet over here, and I'll just select these and hit Control-C to copy it, and then tell it where I want it pasted, and then hit Control-V, and that'll paste right there to block that out. All right, so the braking distance we just figured out is going to be the final speed squared, and we'll put that in there just to keep everything organized, minus the initial speed, which is D2 squared, and then parentheses to tell it that that's the numerator, and then in the denominator we're going to have 2 times acceleration, and that acceleration is this. So this will actually, I think, is going to come out as a negative. So that's 63 feet. So here we can just put in the negative to let it know that the acceleration is negative. Alternatively, you could just put this as negative 0.65, and then everything will work out copacetic. Okay, so that's 63 feet for that. Just checking back with the equation here. So we got that right. Is the final velocity squared minus the initial squared over 2 times the acceleration. So turns out that the braking distance is very similar to the PRT distance. The PRT distance, we have 66.7 feet and then 63 feet. So now we know that the total distance is the summation of those two things. So you can do that a couple different ways. Again, I'm just gonna, so let me show you a couple of things here. You can do Control-C, Control-V, or you can hit Control-Z and get back to where you were, and then select both of these cells. And this comes in handy in a lot of situations. There's a little tiny green handle here, and if you pull down on that, it'll copy it. So that's kind of a little shortcut that makes things easier. So now the total distance is going to be equals the braking distance plus the PRT distance, and that's 130 feet. The alternative is if there's cells, a lot of cells next to each other, you can just use this function, equals sum, and then that the values that you're interested in separated by a comma and the parentheses. So that'll do the same thing. So for instance, say that you had just some random numbers here and you were interested in putting in the sum of those values here. You can just type equals sum, open parentheses, and then drag, click and drag on those cells, close parentheses, and it'll tell you the summation of all of those. So the great thing, of course, about Excel is that this is all live. So if I change the 2 to 18, then it's going to, in real time, update the tally below. Okay, so I'm going to delete that. Now the question says plot the stopping distance from 35 to 50 miles per hour in 5-mile-an-hour increments. So you could set up your spreadsheet originally to be able to handle this, or you can just type in, change the values in your calculations and fill in a table. So that's what I'm going to do here. So we're going to say initial speed, and we'll do 35, 40, 45, 50. I'm going to center these. I'm going to center everything here actually. And I'd like to just make sure about, identify what the units are going to be. Initial speed and then stopping distance. Feet. And that's total. So it's interesting. This one automatically formatted to the cells to the left of it, and this one didn't. So it's a good opportunity for me to show you the format painter. So if you select the cell that you want to apply, so you're going to take the formatting from this cell and apply it to other cells. So select that cell and then click on the format painter and then click the cell that you want to apply that formatting to. And that makes things a lot easier than bolding things, changing the color of things, and going through that whole process. Okay, so at 35 miles an hour, we know that the answer is 129.7. We can go in here and go 40 miles an hour, and that's 158.6. 45 miles an hour is 190. And then 50 miles an hour is 223.9. Okay, so at the 190, it didn't give it that extra decimal to keep things clean. I like to have everything with the same number of significant digits. So here's what we're going to use to create the plot of the stopping distance versus the initial speed. Okay, so to do this, there's a million ways to skin a cat when it comes to creating a graph in Excel. So the way that I like to do it so that Excel doesn't get any ideas about what I'm thinking, which often it will, you'll see. But if you hit insert up here, that'll bring up a whole new ribbon, and then there's a charts section. So I would go here, you can see you can do a scatter, which just puts the data points, it plots the data points on the XY, or you can have a line in between them. And it's not a huge commitment. Whatever you select there can ultimately be changed down the line. But this just gives you a blank chart, blank graph. So that's the way that I like it. Ultimately, I'm going to click on this chart, right click, and hit select data. So here I'm going to add a series, and it's going to be called stopping distance. That's what we're going to be plotting. And the X values, once you're in here, you can see the cursor blinking in here, then you can just go to the spreadsheet and select the X values. And then on the Y, if you click this little arrow, it allows you, at that point, it collapses the pane a bit and allows you to select what you want for the Y. Then click back on that arrow to get you in, and then you can hit OK. And now you have the stopping distance plotted versus the initial speed. So here I'd like to do some formatting, as you might expect. First of all, I'm going to double click on the X-axis, and that brings up this pane here where I can tell what I want the minimum value to be and what I want the maximum value to be. Here we did 35 to 50, so that's all we need to see. So we'll do 35 to 50. And then it has the major unit as 2 miles an hour. I'm going to change that to 5. Actually, let me do 2.5. I think that might look good. So we'll do 2.5. Similar to what you're doing in the spreadsheet itself, you can change the number of significant figures on the labels for that axis that you're dealing with. So here I'm going to tell it that it's a number, and I only need 1 decimal on there. Okay, so the X is pretty much set up, and now the stopping distance goes from 130 to 224. So I'll just do 100 to 250. I think that'll probably look good. So double click on the Y-axis, type in 100, and then let's go to 250, and that should be good. So, and I'm gonna have the major be 25 miles an hour. And here, I don't need the anything after the decimal. I can have 0 decimal places for that, just to tidy it up a little bit. Okay, so the last thing I like to do is just label everything. So if you click on the graph area, then you can go to quick layout, which is generally what I do, and just select this top left one. And that gives you a legend, which if you have several things plotted here, then you'd want to keep that. But here we only have 1 thing plotted, so we can delete that. And then the axis title here is going to be initial speed, miles an hour. And the Y-axis title is going to be stopping distance in feet. Okay, and now that's all set up. So now you have a nice presentation regarding how the stopping distance varies with the initial speed, and you can therefore interpolate in between anything. And sometimes, so this one's a very simple example, but a lot of the times I will do something similar, put it in my binder for the inevitable questions from the attorney that say, well, okay, you have the stopping distance as 125 feet or whatever, 130 feet at 35 miles an hour. What if the motorcycle was initially traveling 42 miles an hour? And you can just kind of use this as a quick reference and say, oh, it's right about 155 feet or whatever it is. So that's really handy. Of course, one of the benefits here is that once you have this set up, if new information comes in, for instance, say that we later find out through additional evidence that the rider was only using the rear brake. So instead of using 0.65 Gs, you want to use 0.37 Gs. So you could just go in here, change to negative 0.37, and everything updates in real time. Similarly, if you found out there was video from a surveillance camera nearby that indicated that the PRT was actually 1.5 seconds, you could change that on the fly, and everything updates. So it's really valuable when you're evaluating how much the parameter or certain parameters affect your calculations and conclusions. And again, it's really valuable when you're doing sensitivity analyses, and indispensable when you are doing a Monte Carlo analysis, which is a statistical analysis to figure out how confident you can be in your answers. And we'll talk about that on the last day of class, and we'll get into some Monte Carlo stuff. In the Monte Carlo spreadsheets might look intimidating, but we're basically just doing exactly what we did here, but 10,000 times. So you'll just be copying and pasting a specific mathematical formula down 10,000 rows. So hopefully this helps you gain some understanding of Excel and get more comfortable with it. I would recommend going through this process. If you're not very familiar with Excel, and I'm sure a lot of you are, but if you're not, I would recommend prior to showing up for the class, going through this example that we just did and trying your best to understand everything that we did. If you have any questions, feel free to reach out to me, reach out to a colleague and ask them to walk you through it. We will take baby steps in the class with respect to Excel and get you comfortable with it, but ultimately it's going to be a smoother process for you if you show up to the class having a certain understanding of Excel. So I look forward to seeing you guys in the class, and thanks for watching.